Hey everyone, lesson 4.2 is arc length, which is basically kind of the perimeter of a circle, just a chunk of it. So the way that we set it up is to recall what it means to have a radian measure of 1. So here we have a radian measure of 1, and the reason is that, remember, radians, 1 radian is defined to be where the radius r matches up with this length, this outer length, which is called the arc length of r. So if we play around with these numbers, I can say that if my angle is 1 radian, which is in this sense, that the arc length is equal to the radius r. If we double that and we have 2 radians, so that would be 1 plus another, so the total would be 2 radians. That is equivalent to, if you can count up all of the the outer circumference, you can say, okay, that's 1 plus another r, so that's 2r. And then also in this example, if you take half of a radian, like this, right, that implies that the arc length would be half of r. So in this general formula, as long as theta is greater than 0, so we're not going to deal with negative theta, we can say that any angle in radians, so it has to be in radians, the arc length would equal theta because that is the angle measure in radians times the radius. Okay, so if you solve for theta, you have that arc length is over radius is equal to theta. Arc length, we're going to be using the letter S to represent arc length, and we'll show you the formula. So it says, in a circle of radius r, let S be the length of an arc intercepted by a central angle with radian measure theta greater than or equal to 0. Then the arc length S is equal to the radius, which is right here, times the central angle measure, and that has to be in radians. So if you're ever given degrees, you have to convert it to radians, okay? And S is, like I said before, the arc length. So first example, in a circle of radius 3 centimeters, what is the arc length S of an arc intercepted by a central angle of theta pi over 6, 5 pi over 6? I don't know if I've really emphasized the central angle. We have talked about it, but if you have 5 pi over 6, well, I mean, you don't even have to draw the picture to answer this question, but 5 pi over 6, it's not quite all the way over to pi, which is right here. So just to kind of give you a visual, here's my central angle. Central angle meaning it comes from the center, and then we want to find the arc length. So we want to find this part, this length from here to here along the circle. So this outer edge. All right, so we use the formula S equals, R is in radians, which is or theta is in radians. R we know is equal to 3, and we know that theta equals 5 pi over 6. So 3 times 5, sorry, my 5's look like S's, over 6, which is equal to, you can cancel that, that's 2. So it's 5 pi over 2. So if we do 5 pi divided by 2, that lands us at 7.8, I think it was, let me put that back up, 7.85 we'll say, centimeters. Okay, because that's our unit. So this length is 7.85 centimeters. Now think about, just as a little aside, what is the circumference of this? Well, if you recall, circumference of the circle is 2 pi r, right? So it's 2 pi times the radius, which is 3. So that is 6 times pi. If we calculate that, well, what is 6 times pi? Well, let's just find out. 6 times pi, that is 18.849. So we'll just say 18.85. which is approximately 18.85 centimeters. So this circle, the entire distance around is 18.85, and I'm drawing it away, but you guys get the picture that this outer edge that all the way around is 18.85. So does it make sense that, yeah, that's 7.85 centimeters is a portion of the circle. It's not quite all the way halfway there. That would be 9.4. All right, but we're almost to half. So 7.85 sounds like a reasonable answer. Now I'm going to show you my other crazy way, and you can just say la 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 la, I can't hear you. But I really think it's important to think about this. And I set up a ratio. So if you ever forget this formula, which I do all the time, I just think of it kind of as a proportion. And I showed you guys this with converting when you're converting radians and degrees. So I say, okay, the central angle of whatever it is that I'm looking at is to 2 pi. That's the entire way around, right? In radians. So this has to be in radians as, it actually doesn't have to be in radians. It works with degrees, and I'll show you that in a second, as arc length. So we can say arc length, or S, is to 2 pi r. Okay? Which is essentially the same because the 2 pi's actually always cancel out. Do you see that? And if you solve it, you'll get the same formula as you did up here. And I think that's important. And you can just set it up. So the central angle was given to be 5 pi over 6 is to 2 pi, as the arc length, and that's what we're trying to find, that's S, is to 2 pi times the radius, which is 3. I'm going to cancel my 2 pi's. Okay, and I'm going to put this 3 on the top. So this is the same as 15 pi over 6 is equal to S. We cancel the 3's and we have 5 pi over 2, which is exactly what we had before, 7.85, which I think is kind of nice to, if you get stuck, if you can remember this idea that it's basically part of the whole, right? The whole, in this case, is all the way around 1 full unit, so that measures 2 pi radians. And then the part is the central angle measure. And then on this side here, we have the arc length, which is just a portion of the circumference of the circle, is to the entire circumference. So this is the entire circumference of the circle, right? So for some example where you're asked to find arc length, given that the central angle right here is 55 degrees and r is equal to 2 feet. So you can do it the traditional way, and you can convert from degrees to radians first. So from degrees to radians, our formula is that you take pi over 180 and you multiply that times 55 degrees. And you get your radians. So we're going to use our calculator, and we're going to say pi times 180. Whoops, excuse me, not pi times 55 divided by 180 gives you 0.9599 radians. 0.9599 radians. Okay, and then you can use the formula. So you have that the arc length is equal to radius first, so it's 2 times 0.9599. All right, and if we calculate that, we can just multiply for more accuracy times 2, and that's going to give us an arc length of, whoops, disappeared, 1.91, let's just say 1.92 feet. 1.92 feet. Now, I have a better way, I think, of doing this where you don't actually have to even convert to radians. Because remember how we were talking about part of the whole? Well, you can do that with degrees. So I can say 55 is to 360 degrees. That's my part of the circle, with the whole all the way around is 360 degrees. And that is the same. So that is to the arc length as arc length is to the circumference, and that is 2 pi, and r is 2. Okay, so when you solve that, you just put the 4, this is 4 pi, right? So I'm going to bring the 4 pi up to the top. So I have 4 pi times 55 divided by 360. 4 goes into 360 90 times. So now we know that S is equal to 55 pi over 90. You could simplify that more, but let's just use the calculator to make sure that the answer is the same. So if we have 55 times pi divided by 90, we get 1.919, so 1.92. That's what we had before, 1.92 feet. So that's exactly the same answer. I don't know why, but I prefer this way because then it's less memorizing in my opinion. The only thing you have to know is circumference of a circle and then the part of the whole thing. But this formula is actually really handy when you're doing some of the application problems that we're going to look at next. So with this handy formula here, we can convert that by solving for theta, and theta would equal arc length over the radius. So if you're given arc length, which for some, this example has 8 feet, and the radius is 2 feet, we can say that the central angle theta is equal to 8 over 2, which is equal to 4. That's measured in radians. Remember, this formula is in radians if you use it. So if we wanted to convert to degrees, we would just say that 180 over pi times 4 would give me my degree conversion. So we're just going to have to use the calculator for that. And we can say 180 times 4 divided by 700. I was doing my math in my head. Divided by pi, which is approximately 229, whoops, I always do that and then it disappears, 0.18. So I wanted to discuss a couple of these examples because I think they're great, and you have a rope that's attached to a wall in two places at A and then down here below. And we know that the distance between this AD and D, we can call it F just to be sure, is the same. And so they want us to find this length around this rope, basically the length of the rope around this pulley of some sort. So to do that, this is I love this because I'm a visual person and I love to break down things and try to find angles and right triangles, and now you get to see all of your trig at work with these problems. So do you see that this point, and this is going to be essential to solving these problems. We're going to deal with a lot of tangents of a circle. Remember that a tangent, if a line is tangent to a circle, it forms this right angle right here. Okay, so now I have a right triangle all of a sudden, and I know that one of the legs is 2. All right, I also know that this is another right triangle, and the way that the book is doing this, the example, is the idea that if I can just find the upper half of the rope, which is A to C basically, if I can find this part, then I can just multiply that times 2 and I'll have the length. So for the first part, I notice that this is a 3, 4, 5 triangle, and you could use the Pythagorean theorem with that right triangle. Now, this is another right triangle, triangle ABE is a right triangle, and they talk about that as well. So you can find that length by doing your, this is the hypotenuse because it's opposite the right angle from B. So you have basically 2 squared plus A, to find AB squared is equal to 5 squared, and that's where they get the square root of 21. So we've got the square root of 21. We know that that is the distance AB. All right. And then we need to find arc BC. So our strategy, our plan of attack is to take 2 because we're going to double it, length AB plus arc BC. Okay, so all we need to find, we've already found AB, is we need to find what the measure of angle BEC is. And so to do that, if we can find the measure of this angle, which we can because this is a right triangle, angle AED, and also angle AEB, this angle, we can subtract that from 180 degrees, and that's what they're doing. So in the first ratio, tangent of AED. So tangent of AED, that's this triangle right here. This angle, the opposite is 4 over 3. So if you do tan inverse here, that's tan inverse of 4 over 3. Now the thing I wanted to warn you, if you're using your calculator, and you're dealing with, if you want to deal with degrees, that's fine, but you're going to have to convert back to radians. So the book decided to go with degrees, right? But I would check, and another way I want to show you is if I want to go into radians here, so I'm going to scroll down, select radians. You can just do this all from radians. So if I say, okay, tan inverse of 4 divided by 3, close my parentheses, that gives me 0.9273 radians. So this is also equivalent to 0.9273 radians. All right, cosine AEB, that is this angle right here from angle AEB right here. So to do that, that's adjacent, which is this leg 2 over 5. So once again, if I decide to do that in radians, I have, and let me move it over, that cosine inverse to find this angle in radians would be 2 divided by 5, close those parentheses. What do you get? You get 1.1593. So 1.1593 radians would be angle AEB right here. Okay, so then they subtract that from 180 degrees, but we wouldn't subtract it from 180 degrees. We would subtract it from pi. So it's pi minus 0.9273 minus 1.1593, and that's also equivalent to angle BEC. I'm not going to do the math. You guys can confirm or verify that that works, but you should get for that 1.06. So let's just do it. Now I want to do it. So we have pi, because that's half of the circle. That's 180 degrees. That's equivalent to pi. So then you can do minus 0.9273 minus 1.1593, and that is our 1.05. Do you see how that's the same? They have 1.06. So 1.05, we already know it's in radians. Okay, and then I even think it's probably a little more accurate. And so if you multiply that times, because this is the arc length, BC is arc length, because BE is just the radius, so the radius is 2, and then you have your 1.05 radians, and that gives you the total distance of the rope, 13.4 feet. Okay, so I'm going to include a blank image of this one to help you guys with number 5 if you'd like. You can also just draw the diagram. But number 5, if you read it, it says that the centers of 2 belt pulleys with radii 3 inches and 6 inches respectively are 13 inches apart. So I just wanted to help you set this up. You've got your 3 inches, so that would be this radius. So we have 3 inches here, and then the radius of this circle, so that would be BG, is 6 inches. So that's the entire distance right here. And we know that these are 13 inches apart, so from the distance from A to B. Okay, so what they're doing, and in the example, this is very similar to the example in the book, so please read example 4.7. So see example 4.7. And they have another thing that you can look at. But what they do is they say, all right, see how we can create this? This is also a tangent, and I'm going to connect this tangent, and I'm going to extend my radius up to this, and I'm going to create another circle. And basically, I want this length to be 3. So then this length, CB, is also going to be 3 because that's 6 minus 3. All right, so that would be the total radius minus this 3 here. And you can do that, and you can also create, this creates another tangent. So this becomes a right angle right here. This is a right angle. And so we have a lot to work with here because we know that the length AB is 13. We also know that this length is 6. So when you're setting this problem up, and you can look at the example, your plan of attack, because you want to actually find all of the blue. You want to find the rope around the pulleys. Okay, so that means that if you think about it, I need to multiply. I'm going to double all of the top. So I have arc DE plus distance EF plus FG, and I multiply, that's arc FG. I multiply all of that by 2, and that would give me the distance of the rope. So look at the example and see if that makes sense. If you can always come and see me if you have questions about it. I'm going to give you a couple more hints. This is 90 degrees. This is your right triangle. You know this side and this side. You can find this side by Pythagorean theorem. So find AC by Pythagorean theorem. One other thing I want to point out, which the book does too, is that this distance right here, this angle ABC, is the same as this angle. Okay, and you can see that kind of by the slant, and basically it's a transversal cut by two parallel, intercepting two parallel lines. So DAE, which you need to find for this, is the same as ABC. But look at angle ABC to find that, because angle ABC, we could say using, we have an adjacent leg, and we also have the hypotenuse here, right? So the cosine of angle ABC is equal to the adjacent leg, which is 6 over 13. You can choose to keep that in radians, or you can choose to keep that, or to put it in degrees in your calculator. Make sure you're in degree mode and then convert it back to radians. That means that also, important to find, we need this central angle. Okay, so to find this central angle, you just take this angle and you subtract that from either pi if you're dealing with radians, or 180 degrees if you're dealing with degrees. Okay, so for number 6, I just wanted to point out a couple of things. You know that the radius of this circle is 1/2. So given that, you can say, and it's a 1/2 foot, so we're measuring this in feet. And you're supposed to find basically the distance of basically the blue again. You're supposed to find the length of this rope. So break this down into some fun triangles, play around with it, but one thing that you can do, I want to point out that this length right here, you know, is 6. This is another right triangle here, right? And it's also given, and I just said, okay, call this length, if you extend this up and this over, I'm going to call this length from here to here X, and then I'm going to call this length basically from here to here Y. So if I think about it, see how X kind of goes beyond this circle? But do you see that this little circle, or this excess here, is 1/2 a foot and 1/2 a foot here? So if you think about this, we can say that the length of the rope is equal to X plus Y minus a half from the first x right here, minus another half. But then we have to tack on the actual arc length. What is the arc length? What is the central angle here? The central angle is 90 degrees, or even better, that angle is pi over 2 because that's in radians. Okay? So then plus this arc length, well, I'm just going to let you guys decide that, arc length of 1/4 of the circle. Okay, so you guys think about how you can find x given this, so x would be the entire distance around, given this angle, and then think about how you can even find this angle if you know that this is a right angle. So I think I've given you enough hints. I hope I didn't give you too many. For number 8, I just want to point out, so this is number 8, that this is a right angle because it's tangent, all right? And basically, if you can find this distance that I'm going to put in the pink, whoops, from here to here, then you can just multiply that 4 times the pink to get the answer, the total length. Okay? And same kind of idea. If you're setting up arc length, you can think about from here to here, you need to find this measure of that angle. You already know the radius is 2, right? And then this distance has to do with a right triangle. You know this length too, because that's half of 10. So this length is 5. So Pythagorean theorem for this part, finding the angle for this part, you can first find this angle, right? Using a trig ratio because you already know 2 sides. So find this angle, then subtract it to find from pi, if you're keeping it in radians, to find this angle. So I find this stuff really fun and interesting. It's kind of like a puzzle, unraveling the puzzle. So please, you've got until next week. Give me a call or an email if you have any questions. Go see Sam at the AAC. But don't wait till the last minute to work on these. Okay, this is the end of the lesson. Have a good day.